6 of the selfish gene. Nope, got that wrong. Let's restart the whole thing. Just kidding. Alright, chapter 6. Today we'll be talking about genesmanship. Now, you might think that this would be like, hey, this DNA just graduated DNA University. Salute him! Or all that kind of fancy stuff. No, obviously there will be no fancy stuff. DNA University doesn't exist. However, it does have something to do with DNA. Now, DNA has lots of multiple effects on its own little host and stuff. What is a selfish gene? It's not just one little part of DNA. Just as in the primordial soup, it is all the replicas of the particular bit of DNA distributed throughout the world. And if we allow ourselves to license of talking about these genes like that, then we could probably get a lot to really talk about here in theory, and assists its own survival in the gene pool itself to get their survival machines to start behaving in ways that are probably altruistic or other ways too, which might actually be one of the reasons why some things seem to happen. Now, it is true that genes do have multiple effects. It's just that some of those effects aren't just activated. As emphasized in chapter 3, it is theoretically possible that a gene could arise which conferred an externally visible label, like, say, a piece of pale skin or green beards. I've never seen a person with green beards though. And this kind of gets us to the next part, the green beard altruism. In fact, meaning that people with green beards are more likely to help people who also have green beards. This effect seems to be happening throughout the life, and it for some reason seems to be one of the driving forces throughout the nature. And the thing we want to calculate is the probability or the odds of all of this happening. That, like, two individuals, say, like, sisters, share a particular gene. They would probably do, unless one of them was kidnapped from someone else and adopted, that is. Let's just ignore that. And I have good news. It involves lots of math. Yeah, I don't really like math that much too, guys. At least the way I explain it kind of boring, so we'll probably have to skip lots of it. But first of all, let me just give you an outline. Let's just say there is lots of people, and let's just say that you have an ancestor of these guys. Let's call them A and B. Yeah, Richard Dawkins was not a good guy at naming things. But once you have found a common ancestor of A and B, it is of course logically true that all his ancestors are common to A and B from that point on. A himself is the common ancestor which we are looking for, and having located them, count the generation distances as follows, and starting at A, climb up the family tree until you find a common ancestor, and decline down to B, and the total number of steps of the tree and then down again is that generation distance. And that's pretty big too. That's pretty big. It's like double your number of things, to be honest. And that's just one of the things, to be honest. Lots of generations and generations. Everyone has a common ancestor, the very first living thing. Everyone. If two people don't really have, at least two people will have at least one common ancestor. And if two people don't really have a common ancestor and they go on infinitely until they reach to like the beginning of life, that means that the first living being is their common ancestor. Also, it probably doesn't look like it. Then you apply some math, and you'll be able to do lots of good things with all those results, and probably ace your test results too. If you copy and calculate lots more things, you could actually get individuals to do things yourselves. I mean, kin selection is just one of the ways to actually reproduce. You can, like, select kin. Should people even have favorites or not? And that's pretty important too. However, what about parent altruism? Basically, that would mean parents would do lots of other things too. Some people actually use the term kin selection to distinguish the kind of natural selection from group selection, which is different of the survival of these things. Lots more math included here. There's much more that we have not discovered yet. Oh, this book is 4 years old, like 50 years old. However, it's still not that much changed. So that's pretty impressive. Don't take my word for it. Read it like a sci-fi novel. And so that is the end of today's episode. See you guys soon. Shanana out. Peace.